AI feels like it just appeared out of nowhere, right? But the truth is, it didn't just show up one day when someone flipped a switch. It actually has this long, messy, and totally fascinating history. It's a story full of brilliant ideas, spectacular failures, and at least 2 deep winters where the whole field nearly froze to death. So let's dive in, because to really get a handle on where AI is going, you first have to understand where it came from.
And this entire story, believe it or not, starts with a question. Not a computer, not a line of code, but this one simple, profound question. Back in 1950, the legendary British mathematician Alan Turing published a paper that basically kicked off this entire multi-trillion-dollar field by asking, can machines think?
Now here's the clever part. Turing didn't really try to answer his own question head-on. Instead, he came up with a test. He said, look, if a machine can have a conversation with you so well that you can't tell if it's a person or a machine, well then we'd have to consider it intelligent. This Turing test basically turned a philosophical game into a real concrete engineering challenge.
So you really have these 2 birth moments for AI. First, you've got the intellectual spark from Turing in 1950. Then, just 6 years later, a group of researchers get together at Dartmouth College, and they give their new field its official name, artificial intelligence. I mean, the mood there was electric. One of them actually predicted that machines could do any work a human could do within just 20 years. Talk about optimistic.
And that incredible optimism, it fueled the first great wave of AI research. But, like a lot of waves, this one was destined to crash hard. This was really the first major hype cycle for AI, a period of incredible promise followed by a very, very harsh reality check. And things move fast. The question gets asked in 1950, the field gets a name in 56, and by the 60s, you have these early programs that seemed, well, magical. But that excitement soured, and by 1973, a pretty devastating government report came out and effectively pulled the plug on the funding.
And you can't blame them for getting excited. I mean, these early programs were genuinely impressive for their time. There was this program called ELIZA, built back in the 60s, that could mimic a psychotherapist, and it was so convincing that some people actually thought they were talking to a real human. Sound familiar? Yep, you can draw a straight line from ELIZA to the chatbots we use every day.
So, if it was so impressive, why did it all fall apart?
Well, because these programs were really just clever tricks. They weren't actually intelligent. They were just following a set of pre-programmed, hand-coded rules. They couldn't learn, they couldn't adapt, and the second you stepped outside their tiny, little predefined world, they just broke. This big collapse became known as the first AI winter. That gap between the hype, what was promised, and the reality, what was delivered, had turned into a giant chasm. Governments had poured in millions expecting science fiction, and what they got back were, well, glorified toys. So the money dried up and the whole field went into hibernation.
But AI didn't stay frozen forever. In the 1980s, it came roaring back, but with a whole new strategy. This time, instead of trying to build a general, all-purpose thinking machine, researchers focused on something much narrower, capturing specific human knowledge. This was the era of the expert systems.
The idea was actually pretty simple. You'd interview an expert, let's say a doctor, and you try to turn all their knowledge into thousands of if-then rules. If a patient has a fever and a rash, then the system suggests a possible diagnosis. And these things actually worked. For a while, they were a huge commercial success.
But they had a fatal flaw. They were incredibly brittle. Think about it. The world is always changing. New medical discoveries are made, new financial laws get passed, and every single time something changed, a person had to go back in and manually rewrite thousands of these rules. It was a total maintenance nightmare. So by the late 80s, the market for them collapsed, and that brought on the second AI winter.
And that brings us to the modern era, the third wave of AI. Now, this wave didn't start with a big bang. It started quietly, in the background, while other things were stealing the headlines. The whole focus shifted away from programming rules and towards creating systems that could actually learn on their own.
The big public moment everyone remembers came in 1997. That's when IBM's Deep Blue computer beat the world chess champion, Garry Kasparov. He even said it was like playing against a god. But here's the secret. Deep Blue wasn't thinking. It was a brute force calculator, a monster, analyzing 200 million chess positions every single second. It was an incredible engineering achievement for sure, but it wasn't a learning machine.
The real revolution, the one that truly mattered, was happening away from the TV cameras. Researchers were dusting off this old idea from the 1950s called neural networks. systems that were loosely inspired by the human brain and could learn from data. For decades, they just didn't work that well, but now finally, computing power and the amount of data available were catching up to the theory.
Then, in 2012, everything changed. There was this big computer vision competition, and a team led by a researcher named Geoffrey Hinton used a deep neural network. They didn't just win, they completely obliterated the competition. Their error rate was almost half that of the runner-up. The entire AI world just stopped dead in its tracks. Everyone knew the game had changed.
And that was the birth of the deep learning revolution.
Suddenly, this was the only approach anyone cared about. All the major tech companies basically pivoted on a dime, pouring billions of dollars into this new way of doing things, pioneered by Hinton, who today is often called the godfather of AI.
The final, crucial piece of the modern puzzle fell into place in 2017. A research paper from Google introduced a new kind of architecture they called the transformer. This is the innovation that unlocked the incredible power of large language models. In fact, this is what led directly to the tools we all use now, like ChatGPT.
And the rest, as they say, is recent history. When ChatGPT was released, it hit 100 million users in just 2 months. No app in history had ever grown that fast. Suddenly, AI wasn't just some research project in a lab, it was a tool in the hands of millions of people. So, after that long and winding journey, what's the big takeaway? What's the fundamental pattern of AI history that helps us make sense of what's happening today?
It's this. Progress in AI is not a steady, upward climb. It's more like a series of violent, exciting explosions of progress, followed by long, quiet plateaus or even those devastating winters. We've seen at least 2 of these full cycles. Right now, we are living through the third, and by far the biggest explosion.
And that leaves us with a big question, doesn't it? When you look back, you can see the explosions of progress are getting bigger and bigger, and the winters, or the quiet plateaus, seem to be getting shorter. This current wave just feels different. The scale of it, the speed. So you have to ask yourself, is this time truly different? Is this the explosion that doesn't end? That's the question we're all grappling with right now.